So we're going to learn about finding orthogonal trajectories, and we're going to start off with this example from class. So the example that we're starting off with is x equals, just so you can see it, x equals k times y squared. So this is our family of parabolas that are shaped not up and down, but left and right. So we've got a family of parabolas that go to the left and to the right, and we want to find all of the orthogonal trajectories to this family. There are two main steps for finding orthogonal trajectories. The first is to find a differential equation for the given family, and then the second is to solve this brand new equation, which is y prime equals negative. Here's our new differential equation, y prime equals negative 1 over f of x, y. Because remember, as we talked about in class, how do you know that two curves are orthogonal at a point? Their slopes have to be negative reciprocals of each other. So if I take the slope of, my parabola at a point and multiply it with the slope of that orthogonal trajectory at that same point, the product of my slopes should be equal to negative 1. Because remember, if your slopes are the same, then if your lines are parallel, then the slopes are the same. If your lines are perpendicular, the product of your slopes is equal to negative 1. So if I know that f of xy is the slope of the tangent line to the curve in my family, then the negative reciprocal is going to be the slope of the orthogonal trajectory at that same point. So this is going to be the slope of the orthogonal trajectory, because when I multiply these two together, if I multiply f of xy by negative 1 over f of xy, then I get negative 1, which is what I want. I want the product of my slopes to be equal to negative 1. Okay, so let's go ahead and do step 1, which is to find a differential equation for the given family. So I've got to find a differential equation for this family of parabolas. Now, how do I find a differential equation? I'm just going to start by taking derivatives. So if I start off with x equals k times y squared. Now remember, k is a parameter, so k can be any value. And I'm just going to take the derivative with respect to x of both sides. On the left-hand side, what's the derivative of x? It's just going to be 1, right? And on the right-hand side, I'm going to need to use chain rule, right? Because remember, y is actually a function of x. So when I use chain rule, the derivative of k times y squared, first I can pull the k out because k is a constant. It's just a constant parameter. And now I need the derivative of y squared. That's going to be, using chain rule, 2y prime. Okay, so I've still got my k in front, and I'll have 1 equals k times 2y prime. Now, what is my differential equation? Remember, my differential equation needs to be of this form right here. Y prime equals f of x comma y. So let's try to manipulate this equation to make it look like that general format. So I'm going to divide both sides by k times 2 times y. Divide by k times 2 times y. So now I have y prime equals, now I have 1 over 2k times y. I'm still not done, because so what I have is y prime equals 1 over 2k times y, but I need a function just of x and y, not a function of k, x, and y. So I have to eliminate this k. So see this k, I need to eliminate the k. Eliminate k. Okay, I need a function that is only in terms of x and y. So How do I eliminate k? Well, remember, I've got this equation right here. So my parabola satisfies this equation, and from this equation, I see that k has to be x over y squared, because I divided both sides by y squared. So since k is x over y squared, I can replace k with x over y squared. Now I've got the format that I need. So I've got y prime equals f of xy, and my f of xy is going to be 1 over 2 times x over y squared times y. And I can simplify that to be 1 over 2 times x over y. And I can multiply the top and the bottom by y. So I just get y over 2x. So this is my differential equation, diff EQ, satisfied by my family of parabolas, of parabolas. It is going to be y prime equals y over 2x. Okay. Now, so I'm done with step 1, which is to find a differential equation for the given family. I have found my differential equation. Okay. Now step 2 is to solve the new differential equation, y prime equals negative 1 over f of xy. So I now need to solve my new equation. So I now need to solve this new equation, this new diff EQ. And what is my new differential equation? It is going to be y prime equals negative 1 over f of xy. But what was f of xy? Remember, f of xy was y over 2x. So I'm going to need negative 1 over y over 2x. Okay. So if I have y prime equals negative 1 divided by y over 2x, I can simplify this to y prime equals, multiply the top and bottom by 2x. Okay, so I'm going to get negative 2x over y. Now, I need to solve this differential equation. Solve me to get the orthogonal trajectories. Okay, how do I solve this differential equation? Well, this differential equation is first order, and it is separable. So I'm going to separate the variables. So I have y prime equals negative 2x, and I can rewrite this as y dy dx equals negative 2x. Excuse me. So y dy equals negative 2x dx, and I'm going to integrate both sides. On the left-hand side, I'll get y squared over 2 plus a constant. On the right-hand side, I'll get negative x squared plus another constant. But remember, the constants are arbitrary, so we can combine those and rewrite this as y squared y squared over 2 equals, if I multiply everything by 2, let me just slowly do this step here. So first, I'm going to combine this constant on the left with the constant on the right. So I'll just get y squared over 2 equals negative x squared plus a brand new constant. Now I'm going to multiply everything by 2. So I'll get y squared equals negative 2x squared plus 2 times a constant, which is another constant, so plus a constant. And this is my differential equation. Sorry, this is not my differential equation. These are my integral curves. So these are my orthogonal trajectories. So these curves are orthogonal to the parabolas. Now, what are these curves? We can take a moment and look at that quickly. So we've got y squared equals negative 2x squared plus c. And we can rewrite this as y squared plus 2x squared equals c. These are going to be ellipses centered at the origin. Okay, so you can rewrite it as x squared plus y squared over 2 equals a constant, right? So it's going to be an ellipse. If x equals 0, then y is square root of 2 plus or minus square root of 2. And if y is equal to 0, then x is going to be plus or minus 1 times whatever your constant is. So it'll be c. This will be c. So let's see. If x is equal to 0, then we'll have y squared over 2 equals c. So y squared equals 2c. Y equals plus or minus square root.
9:30.
Thank you. Plus or minus the square root of 2c. So this will be up here, square root of 2c, and this will be negative square root of 2c. If y equals 0, then we'll have x squared equals c. So x equals plus or minus the square root of c. So that'll be square root of c and negative square root of c. So we'll have ellipses, right? And as c gets bigger, right, the ellipses will get bigger and bigger depending on c. And these are apparently orthogonal to the parabolas that we have, right? So we were drawing our parabolas from before, parabolas with the vertex of 0, 0. Okay, and for fun, you can use Mathematica to draw your ellipses and your parabolas and verify that the families are orthogonal. Okay, so just to review, we had 2 steps. The first step is to find a differential equation for the given family. When we found our differential equation, right, we had to remember to start off with the equation for the parabolas here. So start off with the equation for the parabolas. Then we just differentiated. That gave us something like this step right here, this equation. But we weren't done yet because we needed to eliminate k, right? So we went back and used our original equation for the parabolas to rewrite k in terms of x and y. Now we're in a situation where we've got what we need, a differential equation of the form y prime equals f of xy. So that was a step 1, right? Was this step right here, which I guess we rewrote here, right? Get this differential equation. That's step 1. And then step 2 is to solve a brand new differential equation, which will allow us to make sure that our slopes, the product of our slopes is equal to -1. So our brand new differential equation is right here. And this time we were able to solve it using separation of variables because we had a first order separable differential equation. So when you are finding your orthogonal trajectories, you will be able to solve the resulting differential equation using the methods that we've learned so far in this course. Thank you.